Harming people is considered by society to be morally wrong, primarily because of our ability to empathize with other people. However, some people's brains fail to properly generate empathy, which leads to the terrifying emergence of psychopathy. This video is all about how our brains generate empathy, how this process is disrupted in psychopathy, and how your brain regularly simulates psychopathy in response to certain people and situations, thereby enabling good people to do terrible things. Empathy is the ability to share and simulate someone else's experience. And when we empathise with someone who could be affected by our actions, we are less likely to behave in a harmful way. Therefore, empathy is argued to mould and shape our sense of morality and justice within society, and to generate feelings of guilt and disgust when these morals are violated. So let's dive in and deconstruct how empathy actually works. The first component of empathy is called affective empathy, and this is the ability to feel the emotions of other people. For example, feeling the sadness of the person that you are comforting. This is called emotional contagion, and this is where your brain starts simulating the other person's feelings. However, there is also a second component of empathy, which is called cognitive empathy. This type of empathy enables you to intellectually understand other people's mental states, meaning that you are able to make inferences about the other person's perspective, thoughts, and feelings, but without their emotions spreading to you. Cognitive empathy therefore forms what is called the theory of mind, which equips you with the ability to operate within the social world around you. In neurotypical people, both affective and cognitive empathy combine with each other. However, in certain other groups of people, this unification between affective and cognitive empathy does not always occur. As we've just seen, empathy is in fact a dual system, which is formed of both affective and cognitive facets, and as we shall see, are generated by different brain systems. However, even before the development of neuroimaging techniques like fMRI in the 1990s, this psychological duality was proposed by a psychiatrist called Dr. Hervey Cleckley in 1941. Dr. Cleckley was interested in psychopaths, and he described how psychopaths are able to intellectually understand your emotions, without using this information to guide their behaviour. Dr. Cleckley called this phenomenon the emotion paradox, and he described how this enables the psychopath to appear perfectly normal in social interactions, in what Dr. Cleckley called a mask of sanity. Fast forward to the 21st century, and we now know that this mask of sanity is generated by a dysfunctional dual empathy system in the brain, meaning that in psychopaths, neurologically speaking, cognitive empathy is generated, but affective empathy is not. This means that a psychopath can know exactly what it is that you are experiencing, thinking and feeling on a cognitive level, but are not actually simulating your emotional experience within their own brain. And in fact, many studies even report that theory of mind in psychopaths is actually even higher than within the average neurotypical person, perhaps explaining many psychopaths' ability to manipulate those around them. So to wrap up, when it comes to psychopathy, this disorder appears to be a condition which is generated by impaired affective empathy, which impacts their moral judgment and increases their propensity for aggressive and harmful behaviour. But how exactly does the brain use empathy, to generate morals. Affective and cognitive empathy are generated by different brain areas, and whilst affective empathy is generated by regions like the insular, cingulate cortex and inferior frontal gyrus, cognitive empathy is generated by the ventromedial prefrontal cortex. Both of these empathy processes then converge upon the orbitofrontal cortex, or OFC, which is a region directly above your eyes. This convergence therefore enables both of these types of empathy to fuse with each other, so that you experience them simultaneously. This process is obviously very fast, and it provides that instant moral feeling of discomfort and judgment whenever you see something that you don't like. This is because the OFC instantly tags what you are experiencing as being good or bad, based upon its connections with other parts of your brain. So let's start from the beginning. Your OFC is constantly receiving sensory information from the rest of your brain regarding what you see, hear, touch or taste. This sensory information then enters the OFC, for which the OFC has two distinct subdivisions, which split the orbitofrontal cortex into medial and lateral areas. Both of these OFC subdivisions differ in their connections with other brain areas in important ways. Firstly, the medial OFC connects to a network called the reward system, which includes a critical region called the striatum. Whenever you experience pleasure, your striatum starts firing, and this occurs in response to enjoyable experiences, such as whenever you taste sugar, receive money, or experience sex. And it is the part of your brain that is hijacked by addictive drugs like cocaine and ecstasy. Therefore, your medial OFC is part of your reward network, whereby the activation of structures like the striatum causes your OFC to tag what you are experiencing as being good, which increases the likelihood of you re-engaging in that behaviour. And in addition to this, your striatum also activates whenever you do something good for someone else. In other words, whenever you engage in altruistic or prosocial behaviour. On the other hand though, in stark contrast to your medial OFC, your lateral OFC is connected to a system called the punishment network. This network includes regions like the insular and the anterior cingulate cortex, which themselves are critical structures of your pain matrix. And just as the name implies, your pain matrix activates whenever you experience pain, whether the pain you experience is physical or emotional. And not only that, but your pain matrix also activates whenever you see other people in pain, which therefore generates affective empathy. Therefore, the activation of your pain matrix and punishment network in response to your own suffering and that of others signals pain and displeasure to your lateral OFC, causing your OFC to tag these experiences as being bad. Whereas the activation of your reward system when you are helping or aiding others causes you to perceive these prosocial behaviours as being good. Together, both OFC subdivisions therefore drive your behaviour, as they form the neurological basis of operant conditioning, an idea in psychology which argues that our behaviour and perception is driven by learned consequences of our behaviour. And when these reward and punishment systems activate in response to specific behaviours, we therefore call these behaviours good or bad, or more specifically, moral or immoral. Morality is therefore an advanced brain function, one that is generated by the orbitofrontal cortex in its interactions with lower brain circuits. Therefore, the OFC is considered to be the apex of evolution, and accordingly, it is one of the last regions to develop within the brain. As we have just seen, psychopaths have an impaired affective empathy system, which is caused by the pain network failing to adequately activate in response to observing other people in pain. This dysfunctional affective empathy system thereby diminishes the activation of their punishment system, causing the OFC to fail to tag harmful behaviours as being bad behaviours. Altogether, this indicates that in psychopathy, there is a failure within these operant conditioning processes, specifically within their punishment system. And interestingly, of all the abnormalities which are reported within psychopathic brains, the orbitofrontal cortex is the most consistently reported culprit across studies. Here, the psychopathic orbitofrontal cortex is smaller, less developed, and less connected to the punishment network. This means that even if the psychopath's punishment network is activating appropriately, that there is still reduced handling of this information by the OFC itself. This failure to tag suffering as being bad could thereby cause the psychopathic indifference toward people's suffering. However, whilst many psychopaths are simply indifferent to the distress of others, it is well known that many others actively enjoy harming people and have the sadistic subtype of psychopathy. Here, in addition to abnormalities within psychopaths' punishment system, abnormalities have also been identified within psychopaths' reward system as well. Here, the striatum in their brains is larger and hyper-excited, which generates increased sensitivity to pleasurable or desirable behaviours. Furthermore, when psychopaths are evaluated for their psychopathic traits, those who score particularly highly typically show even greater levels of sadism, and are predicted to generate even stronger striatal activity in response to seeing others in pain. Altogether, this suggests that psychopaths' reward and punishment systems have somehow become inverted, causing them to associate antisocial interactions as being rewarding. In line with this, some studies even report evidence that psychopaths experience everyday antisocial interactions as being just as pleasant as everyday prosocial ones. Here, this kind of inversion could potentially occur through either nature or nurture. In nature, through the atypical development of reward and punishment systems, or by abnormal development of the orbitofrontal cortex. Or alternatively, in nurture, through experiences which influence the structure and connectivity of these systems, in what is called neuroplasticity. Consistent with this idea, the orbitofrontal cortex is known to be a stress-sensitive brain region, in which stress hormones have a catastrophic effect of shrinking OFC tissue. This is aligned with the observation that criminal psychopaths report having experienced traumatic childhoods, and of having grown up witnessing or directly experiencing distressing abuse. Altogether, this may therefore explain their distorted moral thinking, as well as the behavioural diversity that exists amongst psychopaths. But as we're about to discover, psychopathic brain states also occur within the general population, through the selective dysregulation of this same moral network, driving ordinary people toward the same evil behaviour. Psychopathic traits exist on a spectrum across the population, and feature mild traits at one end of the scale to the clinical extreme at the other. Here, humanity is capable of experiencing reduced empathy in different situations, and towards different kinds of people. This is a fact which is being increasingly demonstrated in many disturbing neuroscience experiments in recent years. Experiments which investigate the effect of social factors on empathy levels and on brain activity, and which include features such as a victim or a perpetrator's race or sex when judging the committing of certain crimes. Within these experiments, these social factors are called contextual modulators, because they are found to increase or decrease orbitofrontal cortex activity, and the subsequent empathy which is normally generated. And disturbingly, these increases and decreases tend to align with observed prejudices within society. Altogether, this strong ability of contextual modulators to sculpt different ideas of morality, presumably across different cultures and historical chapters, indicate that social factors play a huge role in sculpting the brain's moral system. This ability of social factors to shape moral network activity therefore potentially explains the nature of subjective morality. You can learn more about that in future videos.